All right, so we've talked about how to do divisions. Now let's talk about how to use divisions. So you spent some time in IM2, and also we did some at the beginning of this year, factoring quadratics. And we've also seen in this unit that knowing the roots of a polynomial gives you a lot of information about that polynomial. So how do you find the roots if you have something like this that needs factoring? Here's how. We're going to first take advantage of our graphing technology and see if there are any roots that are easy to find. So take this. Now notice this one says equals 0 at the end. You may sometimes see it without anything, like it could be just x cubed plus x plus 10. Or you might see it with an equals 0, or you might see y equals this, or f of x equals this. In all of those cases, the procedure is the same. We're going to graph this. So I've got my Desmos set up here. So here's a graph of that first polynomial. So that cubic looks kind of like that. Once it's graphed, see if you can use that graph to identify any roots. So I go back to my graph. I know roots that are real numbers are my x-intercepts. So where's the x-intercept? Right here's one. So there is a root at x equals -2. Very cool. So if I have a root at x equals -2, then I know that x plus 2 is one of my factors. So one of my factors is x plus 2. The question then is, well, what would the other factor be? The way you get there is by doing division. So we're just going to take this, x cubed plus x plus 10, and divide by x plus 2. My advice, because we're dividing by a linear factor, let's use synthetic division. So in the box goes the root number, so it doesn't need to be the -2 that goes in, right? Because if that's the factor, it's -2 that makes the factor 0. Next to the third, don't forget the 0x squareds plus x plus 10. Okay, you do your synthetic division, I'll do mine. Ooh, and here's a good sign. Because I know that x plus 2 is a factor, it divides in evenly, there should be no remainder. And sure enough, there's no remainder. Constant x's x squareds. So my other factor is x squared minus 2x plus 5. So we graphed to identify a root. If needed divide, we did need to divide, so there it is. Factor what remains if you can. Now notice we didn't have any other x-intercepts. That means there were no more real roots. That's because this does not factor into real numbers. In order to find the other roots, you'd use the quadratic formula. You're going to find out they're imaginary. I don't expect you to factor something that ends up with imaginary roots. So this is all done. This is as factored as it gets in the real numbers. We had a real root at -2, and now we can actually find the other two imaginary roots if we want to, because we have that quadratic factor to work with. Okay, let's keep going. For the next one here, I would like you to take a moment, pull up your Desmos, and give that a graph. So quick pause, unpause when you're ready to examine the graph. What do we see? I know my real roots are my x-intercepts. So there is a root at -1, at 0, at 1, and at 7. So I'm going to make a note of those. -1, 0, 1, and 7. And actually, that's going to be all of them. Fundamental theorem of algebra says, fourth degree polynomial has 4 roots. We found 4 roots. Let's turn those into factors. I'm just going to make a note here. We had roots at -1, 0, 1, and 7. That means that my factors are x plus 1, just an x, well, x minus 0, that's just x. We're going to typically put that factor in front rather than in the middle. If 1 is a root, x minus 1 is the factor, and if 7 is a root, x minus 7 is the factor. Okay, there you go. Look how easy this can be. If you know the relationship between roots and factors, then this third step, or the second step, if needed divide, we just didn't need to. There are 4 roots. We found all 4 of them. There's all 4 factors. All done. Okay, let's go again. Give that a graph, and then unpause when you're ready for the discussion. Okay, we are looking for x-intercepts. There's one, and there's one. So I have roots at 1 and at 2. Oops. So roots at 1 and at 2. So what do we know? I know that I'm going to have a factor of x minus 1, and I know that I'm going to have a factor of x minus 2. Now here you've got 2 choices. Choice 1, I know there should be 3 roots and 3 factors because this is an x to the 3rd power. You can take this cubic polynomial and do a synthetic division with this factor. Take the result and do a synthetic division with this factor to find the 3rd. Or you can take a closer look at the picture. Notice how it looks right here at x equals 1. See how this graph comes up, just touches, and then bounces back? That's what an even multiplicity looks like. This root of 1 is actually a root twice. That means that this factor is actually a factor twice. So x minus 1, another x minus 1, and an x minus 2, we have found all 3. So knowing your multiplicities can save you a little bit of work there. Okay, these last 2, let's do the same thing. So take a moment, do a quick pause. I'd like you to graph that one on the left. So what do I see? I see 1 real root at negative 5. So 1 real root at x equals negative 5 means 1 factor of x plus 5. To find the other factor, which will end up being a quadratic, we do need to do some division. So the root number goes in the box, the negative 5, because that's the number that would make the factor equal to 0. 9, 25, and 25. All right, you do your synthetic division. I'll do mine. Because this divides unevenly, you should end up with a remainder of 0. So 1 goes down, multiply, add, multiply, add, multiply, add. Remainder, constant, x squared. So our second factor, the one that would lead us to our 2 imaginary roots. Oops, I forgot my coefficient in there. X squared plus 4x plus 5. And if you run this through your quadratic formula, you're going to find that your 2 other roots are, in fact, imaginary numbers. Okay, last one here. Let's wrap it up. Give this a graph. Let's take a look. Okay. So this time our root turned out to be this decimal, this 1.5. So if x equals 1.5, which is also written as 3 halves, is a root, then x minus 1.5, or x minus 3 halves, is a factor. Now, let's do some synthetic division to find out what our other factors should be. So the root is what goes in the box, so the positive 3 halves. Okay, so divided in evenly, constant x squared. So here that is what we have. X minus 3 over 2 times 2x squared plus 2x plus 6. Now, I want to let you know this isn't the only way to factor this. I want you to think back to the synthetic division recording. When you are dividing by a fraction, synthetic division doesn't know if you're using this factor or if you're using this factor. So I want to stress this in blue here that I'm going to highlight is a perfectly acceptable answer. However, if you're not used to working with the fractions, notice how all of these terms here are even. You could divide those all by 2, making this back factor x squared plus x plus 3, and then multiply that 2 through this factor. So 2 times x and 2 times negative 3 halves. Notice how the bottom version that I highlighted green looks more like what we're used to seeing. So if you are doing your practice, and if you check your answer, let's say you get something like what you have in yellow. What is in yellow is okay. But if the answer key says what's in green, this is all that's happening. So if you're not sure whether what you have is the same thing as what's on the answer key, first check in with a friend or a neighbor, and then you can also check in with me. I'm happy to let you know how things worked out.